Assalamu alaikum student, and welcome you all once again student. We are back with class 9th mathematics and the topic is matrices. Student, in the previous lecture we had discussed few types of matrices. Today we will start exercise 1.2 and few other topics like transpose, symmetric matrix and skew symmetric matrix. Now student, in the previous class we had discussed transpose of the matrix. Now what is transpose of the matrix? Student, when you interchange rows with column, it is called transpose of the matrix. Look here, it is a row, okay, and when we interchange it into column, this is a row and we had interchanged it into column. So again, this is second row. Now we have interchanged it into column. Look here, row then column. So it is called transpose of the matrix. Student, keep one thing in your mind. By taking transpose of a matrix, we are also interchanging its order. In case of square matrix, there will be no change in the order of the matrix. But in case of rectangular matrix, we will interchange the order as well. Look here, it is an rectangular matrix. So this is a row. So now we are shifting that row into column. Okay. So now if the order of this B matrix is 1 by 2, now it becomes 2 by 1. So by using transpose of a matrix, we are not only interchange the rows with the column, but also the order of the matrix also interchange. The next thing is symmetric matrix. Student, keep one thing in your mind, that symmetric matrix is the property of square matrix. Okay, so symmetric matrix is that matrix by which we can say that by taking transpose, nothing has changed in this matrix. Look, this is matrix A. So we had changed this. Look here. First row into first column, second row into second column. Okay, so look here, there is no change in matrix A. After taking transpose, there is no change in matrix A. So you can say that matrix A is a symmetric matrix. Once again student, if you calculate a transpose of a matrix and there is no change in that matrix, so that matrix is called symmetric matrix. Keep one thing in your mind. If you have a square matrix, then there is a chance that it will be a symmetric matrix. But if it is a rectangular matrix, there is no chance that it will be a symmetric matrix. Symmetric matrix is the property of a square matrix. Over to another matrix, student. This is another square matrix. Now, first row, change into first column. Second row, change into second column. Third row, change into third column. So again, there is no change in matrix B when we had calculated its transpose. So B is also a symmetric matrix. The next property is skew symmetric matrix. For this matrix, first you have to calculate the transpose. So there is a matrix A. We have calculated its transpose. So first row is interchanged by first column and second row is also interchanged with the second column. Now step 2. When you are going for skew symmetric matrix, the second step is after calculating the transpose that take minus as common. So look here student, what is the effect, what is the impact of taking minus common from that matrix? The sign will be changed. Look here, the sign of plus 3 had become minus 3 and the sign of minus 3 had become plus 3. So now look here student, we have calculated A transpose, but instead of giving A, it has give us minus A. The transpose of matrix A is not equal to A, it is equal to minus A. So you can say that A is a skew symmetric matrix. Okay student. Now student, over to exercise which is totally based on transpose, symmetric matrix and skew symmetric matrix. Page is 12. Exercise is 1.2. The very first question is, find the transpose of the following matrix. Student, this is the proper way, and this is a question you can say of 4 marks. So look here, how would you start after solution? Find the transpose if P is equal to this. This is your P matrix. So look here, give the heading of transpose. Now next, interchange this row by column. Interchange this row by column. So this is the transpose of matrix. So in first question part, he is asking us about transpose. So you have to find the transpose. Now over to another question. That is part 5th. Look here. A 3 cross 3, 3 by 3 matrix is given to you. So look here student. Again the procedure is same. First row is interchanged with first column. Second row is interchanged with second column. And third row is interchanged with the third column. And this is the transpose of matrix T. Now student, question number 1, part 2, part 3 and part 5, part 6. Part 4 are your homework. I am repeating, homework is question number 1, part 2, part 3, part 4 on same page 12. Student, over to question 2 of same exercise 1.2, page is 12. In this question he is asking that which out of 4 matrices are transpose of each other. So for this, just take A and C and you will get your desired answer. Because remember student one thing, that if A is the transpose of B, then B will also be the transpose of A. So first just find the transpose of A. You will came to know that yes, A is the transpose of matrix B, C, D. Okay. So look here, we will start with A. This is matrix A. Find its transpose with the same method which we had done in the question number 1. Now look here student, A transpose is first row is interchanged with the first column and second row is interchanged with the second column. So you can see that the transpose of A matrix is equal to matrix B. Transpose of A is equal to matrix B. So if the transpose of A is equal to B, also transpose of B can also be equal to A. So you can say that A and B are transpose of each other. Over to the third matrix, that is C. Now calculate the transpose of C. Now student, again interchange first row with first column and second row with second column. So what you get? C transpose is equal to D. So you can say that C is the transpose of D also. D is the transpose of D is also C. So you can say that C and D are transpose of each other. So there is no need to solve B and D. Okay student? Over to question number 3 student, and page is same, that is 12, exercises 1.2. He is asking us that which of the following matrices are symmetric. Symmetric property is related to transpose of the matrix. So look here student, this is our matrix A. Okay, first you have to calculate the transpose. So first row is interchanged with first column and second row is interchanged with the second column. Look here student, the transpose of matrix A is not equal to matrix B. Look here, here we have -7 and it is -1. Here we have -1, but in its corresponding position we have -7. So A transpose is not equal to A. You can say that A is not a symmetric matrix. Okay, over to another question. B, look here. First, again the question is same, question number 3 on page 12. You have to calculate the transpose to check the property of a matrix. Look here, first row is interchanged with first column, second row is interchanged with the second column. So look here student, the transpose of B is equal to B as there is no change in matrix B after taking its transpose. So you can say that B is a symmetric matrix. Look here student, question number 3, part 3 and 4 are your homework. Over to question 4. So what he's asking in this question that which of the following matrices are skew symmetric? So student, skew symmetric is slightly changed for that of symmetric matrix. First, calculate transpose, then take minus S common from the matrix. So look here, this is matrix A, this is transpose of matrix A. Look here. Now the next step is take minus S common. Why we are taking minus S common? Because student, we are checking that either A is skew symmetric or not. So for skew symmetric, you will have to take minus S common after taking transpose. So now look here student, by taking minus S common, this minus 4 had become 4 and this 4 had become minus 4. So look here student, this is A matrix. So A transpose is equal to minus A. So you can say that A is a skew symmetric matrix. Okay student. Now over to the next question, that is part 3 of question number 4. Look here student. First of all, again we are checking either this question is this matrix is a skew symmetric matrix or not. So look here student. First we have to calculate transpose, then take minus S common. So look here student, no, this is not same as C. So you can say that transpose of C is not equal to minus C. C is not a skew symmetric matrix. Now student, question 4, part 2 and 4 are your homework. Thank you very much student.